morning everyone. I am Maheswari, APHP Department, R&D Engineering College. This video I am going to discuss about the subject High Voltage Engineering. Subject code is E8701 and the topic of today's session is under the Unit 4 Measurement of High Voltage and Current, and the topic is Electrostatic Voltmeter. So this electrostatic voltmeter is used for measurement of the high voltage AC and DC. So here in this electrostatic voltmeter, the principle of working is if the electric field is produced by the voltage V between a pair of parallel plates disc, the force on the area of the plate with respect to the electrode for which the field gradient is same across the area and it is perpendicular to the surface. So the electrostatic voltmeter, the electric field is produced by the voltage. The measurement of voltage is related to the measurement of force. Okay. So the attraction force between the parallel plates is given as F is equal to 1 by 2 epsilon naught V square A by D square. So in this video, we are going to discuss about the objectives, that is the principle of operation, constructional details and advantages and disadvantages of electrostatic voltmeter. So the operating principle, I'll again explain it. So in this video, it consists of the G terminal and the F terminal, the parallel plates, and M is the moving plate. Okay, G represents the guard rings, okay, and M represents the moving disc, and F represents the fixed plate. When high voltage is provided to this fixed plate, okay, high voltage is provided to this fixed plate, and here you will have a scale which is connected to the light source is connected to the moving plate. So here in this, the construction of this generating voltmeter, it consists of a moving plate M, and G the guarding plate, F the fixed plate which is connected to the high voltage through a series of capacitor. So this is represented as capacitance divider, and D is the dome used. B represents the balance of the bridge, and H represents the guard rings of the bridge. Okay. So it consists of a parallel plate disc electrodes. The moving disc M forms the central core of the guard ring G, which has the same dimension as that of the fixed plate F. The guard rings are used to make the electric field uniform in the central region and it avoids the corona effect. The controlling torque is provided by the balancing weight. The cap or dome encloses the balance and the moving disc. Now the operation of this electrostatic voltmeter, the balance beam carries a mirror which reflects the beam of light. The movement of this moving electrode is amplified through this optical arrangement. Now in order to measure the given voltage with precision, the disc diameter is increased and the gap distance between the electrode is to be minimized. As the gap is more, the uniformity of the electric field is maintained by the guard rings H placed between the electrodes F and M using a capacitance divider. Now, the upper frequency limit for this AC application is determined from the actual frequency of the moving system and the RC behavior of the control spring and the resonant frequency of the lead and stay capacitance of the meter capacitance. Here you can see that the principle of operation. When high voltage is applied, there is more force of attraction of this moving electrode, and with respect to this moving electrode moves, so the light source on the moving electrode will be reflected at a particular angle, and which is measured at using a scale. And now, when the high voltage is increased, more force of attraction of this moving electrode, and thus there is a change in the angle of inclination of the reflected ray, and which is observed in the scale. So we are able to measure the high voltage directly with the help of this electrostatic voltmeter. So operation of this electrostatic voltmeter, a high voltage is applied across the plates F and M. The moving plate experiences electrostatic force. Now the beam of light will falls on this mirror. This light beam deflects on the scale. The angle of deflection varies according to the applied voltage. So here, as I already conveyed you, the force, that is the electrostatic field, the force on the parallel plate is given as 1 by 2 epsilon A V by S square. V represents the applied voltage, A represents the area of plates, S represents the separation of plates, and epsilon represents the permittivity of free space. Now, when one of the plate is free to move, the force on the plate can be measured by balancing it with a counterweight. A small displacement of electrodes of few millimeters is sufficient for the measurement of high voltage, as the force is proportional to the square of the voltage. So, this method of measurement is used both for AC as well as DC voltages. Now, the advantages of this electrostatic voltmeter. Here, the loading effect. It has very low loading effect, as only electric fields have to be built up. Now the voltage source loading is limited to the reactive power, which is necessary to charge the system capacitance, and the voltage up to 600 kilovolt can be measured. If there is any high pressure or vacuum between the electrodes, provide very high resistivity, therefore the active power losses are negligibly small. To the limitations of this electrostatic voltmeter, the circuit calibration is sensitive to mounting and vibration. So higher frequency measurements check to be done on resonance between the load inductance and the meter capacitance. And voltage below 50 volt cannot be detected due to very low field strength. Thank you everyone.